Let us discuss a question from strength of materials. This is a question on thin cylinder engine. Well, it's printed on. It's a thin walled cylindrical shell where the diameter is d and the thickness is t. Now it's subjected to internal pressure. So we are asked what is the ratio of maximum shear. So pressure, we always as default we assume that it's a closed pressure vessel, that is on the axial as well as on the circumferential. It's a closed pressure vessel. Now if you take a small element on the periphery, you have a circumferential stress which is hoop stress, which is again given as PD by 2T, and you have longitudinal or the axial stress which is PD by 4T. There are no other stresses on it. Okay, now these again by force balance, taking a section along the axial direction, you get the longitudinal stress by force balance, and taking a section along the diameter, you get a circumference. So these formulas are well derived and well known to us. So this is the stress state when you take an element on it. Now when you, so this is a case of a plane stress where you don't have any shear stress, but you have, when you don't have any shear stress on this element and you have a 2D state of stress. Now here when we have a situation like this, so now the question is we need to find out the maximum shear stress. So maximum shear stress is nothing but the max principal stress minus the mean principal stress by 2, right? This is how the Tresca gives the definition. So max principal stress, when you have only two-dimensional state of stress and there are no shear stresses, then these two are basically your principal stresses. So this is your max principal stress, this is your mean principal stress, and in fact 0 is the mean principal stress, this is the max, this is the mean, and yeah. So thing is that so max principal stress would be your PD by 4T, PD by, okay, so let's write down, uh, so let's arrange these. So max principal stress is PD by 2T, okay, and this is PD by 4T, and 0 is your third dimensional principal where you don't have any principal stress. So now maximum shear stress will be the max principal stress PD by 2T minus the min is 0, because don't take it, most of the people what they do is they take the min here, but while applying this formula you have to consider all the three dimensional principal stresses. So this you get from the 2D, but third direction you have 0 as your principal stress. Okay, so PD by 2T minus 0 by 2, so this comes about PD by 4T. Okay, so now the ratio of this max principal stress by longitudinal stress, you can see this, they are same, PD by 4T and PD by 4T, so they are same, and therefore the ratio is 1. So the answer is 1, and most of you may end up getting 0.5 because they will consider this as the min. But when you apply this formula, you have to consider max, min, max, all the three, and arrange them in the ascending order. So we have arranged them in the ascending order. This is the max principal stress, this is the mid principal stress, and this is the min principal stress. Okay, so that's the idea. Okay, so the answer is 1. Thank you.